Okay, so 1 second. Okay, so you have a piecewise function, right? I was strongly recommend you graph this. You guys should be pretty comfortable doing the graph without a calculator. So you look at, we have three pieces, right? We have linear, quadratic, and radical. So for linear portion, what's the condition associated with x plus 1? X is, so what I'm going to do is I'm going to do a few tick marks. Hopefully that makes sense. Actually, let me add a few more here. Okay, so x is less than 2 for x plus 1. I'm going to plug 2 in, but you should get a whole because 2 is not included. We know this, right? Because there's no equal sign. And of course, 2 plus 1 is 3. The y-intercept is 1. The slope is 1. X-intercept would be -1. You guys agree with that portion? Does that make sense? Mm-hmm. Cool. Okay. Next up, I'll go green for the next one. We have a parabola that goes between 2 and 4, non-inclusive for both. So if you plug in 2, you should get 2. Again, another hole there. If you plug in 3, you should get 1. Wait. Oh, no. If you plug in 3, you should get a really large number. That's weird. Okay. Um, I'm going to have to increase my tick marks here. 8, 9, 10, 11, 12, 13, 14. Okay. So this is going to be pretty steep. It's kind of threw me for a loop. I thought we were going to have the vertex here. So yeah, plug in 3, you should get 7. 4, 5, 6, 7. All right. And plug in 4, you should get 16. No, 14. There's another hole there. So it's a pretty steep. I kind of missed. So something like that, right? I mean, you've graphed the whole curve, the vertex rate 0, -2, but we don't need to do that. Okay. Okay. Then, for the radical portion, I'll do that in black. Plug in 4, I should get 3. Oh, I'm down black. It's not what, sorry?
I think the -2 just make it like on here. Or
Yeah, but only going from 2 to 4. Right? Because I'm yes, remember it's piecewise. If I made a mistake, because I totally could be missing something here, let me know. So 4, 3, and of course it goes like this. Okay. So it helps to have the graph. Now we can go through this pretty quickly. I mean, you could tell without doing the graph, I suppose, but good idea to do the graph. So it does not exist. You guys would agree? F of 4, we can get that out of the way also. That's 3. For part B, as x approaches 2 from the left side, what are you going to say for that one? Yeah, totally. If I approach 4 from the left side, what are you going to say? 14. Oh, 4 from the right side. 3. So does the limit exist? Nope. How about 2 from the right side? Does that limit exist? Nope. So hopefully we're okay with that. All makes sense? You good? Cool. Okay. Um, okay. No questions. All right, let's keep moving. We've already done something like this already, so this should be kind of review. You're asked to write this as a piecewise function. So you gotta be pretty comfortable with this. So I'm gonna write this a couple times. I'll explain in a moment. And I'm just kind of just go off the rails here a little bit. Okay. All right. So the final answer is that one off to the right. That's what you really want to report. Um, why did I do that? Yeah, I know. I don't do it. I don't know what I'm doing anymore. No. Um, absolute value. Always positive, right? So for example, you have absolute value of x. What's the absolute value of 4? 4. What's the absolute value of -4? Still 4, right? Because absolute value is defined as a distance between a number and 0 and a number line. Right? We know that. It's a positive difference, right? So if I have absolute x of -3, what if x is larger than 3? Would that be okay? Would that be safe to do if x is greater than 3? Would that always be positive in the numerator? Yeah, that'd always be positive, right? That's why the after that could just go away, uh, as long as what is true. X is greater than 3. As long as x is greater than 3, we're okay. We can write like this. It's not a problem because you're still experiencing a positive output. Why did I reverse it when x is less than 3? Because I still want a positive answer, right? So when x is less than 3, like what if x is 2? Have to reverse this because I have to guarantee a positive. If I put in 2 into this, I know I get 1. So how do I guarantee 1 without the absolute value present? You can't write x minus 3 anymore. So if I do, I would get -1. And that would not obey the output we need for absolute value. So I have to reverse it. I have to reverse it. Does that make sense why I kept it alone, left it alone when x is greater than 3, or reverse when x is less than 3? Guarantee a positive output. So hopefully you can see that. So this right here is understanding what absolute value is doing. And understand the fact that, oh, when does we see this change in absolute value? Because that's like x minus 3. You guys know how that graph looks. That's a V shape with what vertex? If you just graph the numerator, what's the vertex of that? 3, comma 0, right? So we know 3 is this transition point. Now I have this. What am I doing with each of these fractions? I'm reducing, right? Of course, what does that become? And this one's kind of weird, but if you could actually factor out a negative from the top. When you have 3 minus x over x minus 3, you could write as negative parentheses x minus 3 over x minus 3. What does that become? Yeah. So that's why you get this. So the graph looks like this. 1, 2, 3, 4. 1, -1. See how that. All right. So this is find the limit of it. Well, the limit does not exist because what's the left-hand limit going to be? If x approaches 3 from the left side, yeah, you get -1, right? And of course, on the right side, so the limit does not exist, right? Okay, we're okay with that? All right, let's keep moving. Totally notes are short today. So these are going to get a little crazy. We're going to do a few more piecewise functions. And then we're done with the notes. So very short notes today. Um, and try to give you guys a head start to get on homework so you can watch the 49ers on Saturday. So but we have a long weekend. We have all the, 3 day weekend's good. But anyway, this is kind of crazy, right? Like find this limit. And I told you, like, you can always just plug in and see what happens. But it's kind of weird, right? Because it's kind of like, oh, well, that looks weird, right? So if you plug in, I'm not sure what to make of that. So what I'm going to do is I'm going to rewrite this as a piecewise function. Okay. What do you think I'm going to put next to these inequalities? Yeah, like I said, I guess that's the same times. Cool. Okay. -2. Why am I doing that? Because if x is larger than -2, isn't that as of x is x plus 2, right? This would be the same thing. What if x is less than -2? What if x is like -3, for example? If x is -3, I should get 1, but you can't try x plus 2 because it'd be -1. So I have to put a negative out in front to counteract it. The reason why you do that, the negative counterpart, is you want to guarantee the positive output when the inside becomes negative, because you have to guarantee that. For example, you guys may not be aware of this, but aspect of x is actually two different things. It's x and negative x. When what is true? When x is less than 0 or x is greater than 0. Because isn't the aspect of x a v-shape? But more specifically, isn't it two linear functions? It's two linear functions. Where one has a positive slope, one has a negative slope. When x is positive, when x is negative. And actually, I reversed that. My apologies. That was terrible. I should know better than that. Okay. So now let's find the limit. We'll see my left-hand limit and my right-hand. Actually, it's the other way around. My apologies. My right-hand limit and my left-hand limit. And actually, hold on one sec. Still running into a problem. Hold on. Hold on. Let me shoot the limit out. Oh, I see what you're saying to use a limit property. Is that what you're saying? Yeah, actually, you're probably right to say that. But it's weird because you still have this infinity nature to it, though. That's the thing. Well, let's do this. We'll do this. Actually, I do agree with what you're saying, Kingston. Let's follow what Kingston's saying. Let me do this. The limit as x approaches -2 from the right side of f of x. It's going to be, so if you plug in -2 from the right side, you could rewrite as this. The limit as x approaches -2 plus of 1 over x plus 2 plus the limit as x approaches -2 from the right side of x squared. So is that what you're suggesting, Kingston?
Yeah, that's what I was thinking.
Okay. So here's the deal. If I do that, if we plug in -2 from the right side, okay. Well, 1 over x plus 2, I know looks like this. So if I put like -1.999999, right? We notice it's going to be infinity plus 4. Or just infinity. You guys agree with that?
Yeah.
Yeah, because if you graph 1 over x plus 2, you get a rational function where -2 is a vertical asymptote. And if again, if you plug a number close to -2 but higher than -2, like -1.9 or 999, whatever, it's going to be positive, but it's going to be a positive infinity value. Now, if I do the left-hand limit, so do that instead, I'm doing this. Of -1, so if I do that, say I do -2.01, here's the thing. If I graph -1 over x plus 2, how does that graph change? It flips, right? So if you think about it, it's still, yeah, on the left side, it's still infinity plus 4 or infinity. So when you're asked to find the limit of this, it's going to be infinity. You could also say DNE. That is also valid because what is infinity anyway, right? It's some abstract idea. But by looking at -1 over x plus 6 in reverse, I'm going to the left hand limit, right? X is less than -2, so like -2.01, whatever. Plug that into the expression, you still get -1 over a negative value. It's still positive infinity. Or just look at the graph. So in this case, yeah, I mean, the limit does not exist, but it is infinity also. So without actually having to graph this wacko function, because I wouldn't expect you to graph more absolute x plus 2 plus x squared. That's, if you go to Desmos right now, it's going to look really crazy. But I like what Kingston said. So Kingston, thanks for the help there. You should teach this class. Um, if we break up using limit properties, yeah, then I can see what's happening, and infinity does make sense. I actually would agree with you there. And
Do you
actually,
specify a positive infinity for this problem or no?
um, if you say it does not exist, I want to know why it does not exist. I don't just saying that, so you have to at least show me what's going on. So that's the only thing. 1 over.
What do you put? What's the answer?
Correct, right. Correct, right. Yeah, and it's such a weird graph. Yeah, you see how like at x equals -2, it starts kind of doing something like this here on each side in -2. So it's definitely going towards positive infinity. If that was a multiple choice question, that'd be a good, like, and I put positive infinity, you know, maybe I don't put D&E as one of the choices. That could be a good question. I don't know. So, all right, last one. This is a good one. Um, this part's a little tricky also. Okay, this might blow your mind a little bit. I know I see some confused looks. That's fair. Totally fair. Because you guys are trying to hold a line. So I'm gonna reveal the truth. Okay. First of all, I know you guys can fact. No problem. X squared plus 4x plus 36, x plus 6 squared. We're okay with that. Here's where you guys have been deceived. Maybe. I don't know. If I asked you what this equals before you took this class, what would you say? Okay, you guys are wrong. Satisfy of x. You've been told a lie. Satisfy of x. Why? Why? Why is that? You need you can only have positive outputs for square roots. Think about a square root function. If you graph a square root function, it looks like this, right? It's not a sideways parabola, because if it's a sideways parabola, would that be a function now? That failed the vertical line test. So it has to have just one output, and it's positive. We know square root looks like this, right? So whenever you have a square root function that's graphed, you have to have one output. For example, root 25, is root 25 5 and negative 5? No, it's just 5. Now, if you have x squared equals 25, sure, you get 5 and negative 5 because it holds two values. Now, why is that different? Because y equals x squared is a parabola. Y equals 25 is a horizontal line. Do they touch twice? Sure. You want two answers. But when you have a radical, like if I say root x equals like 5, fine. Have this, they're going to touch a 25. There's only one answer. I'm not going to have two answers. So that's the reason why we have to have just one output. And the output has to be positive, so it has to be an absolute value. So the square root of x squared is not x, it's absolute value of x. It has to have just one output because it has to be a function. So when you have square root of x plus 6 squared, it's just going to be absolute value of x plus 6. So that's something you guys have not been probably told. Now you guys know. So now we clear up. I'm not saying you guys were lied, but it's a little deceptive because like some textbooks, maybe in middle school, in the fine print, you probably glossed over. So you should probably mention it, but probably didn't say much because they didn't want to confuse you. You just says assume all variables are positive. And a lot of times you do like the simplification problems with radicals, may have done in middle school. Well, we don't say that anymore now. We have to be intentional and put the absolute value. So we have to put the absolute value x plus 6, just saying. Now, can this be written as a piecewise function? Sure, of course. Of course it can. You're going to say this. X plus 6 or x plus negative 1 times x plus 6. Each are true when what is what? When x is greater than negative 6, I can say the positive counterpart. Or when x is less than negative 6, I can say a negative counterpart. Here's the other thing we have to be mindful about too. What if x equaled negative 6? Would that be a problem or would that be okay? It could be okay because you're not going to be undefined. So I do need to put an equal sign either here or here. It won't matter. It's up to you. You can go ahead and either one. So they are going to link up. But that's how you have to write it. If I clean it up just a tad more, I could say this, f of x 2x plus 6 when x is greater than negative 6 or negative 6 when x is less than or equal to negative 6. And by the way, you can put the equal sign next to either the top or bottom, doesn't matter. It's up to you. If I graph it, here's how the graph looks. Put negative 6 over here. Or here. Okay, that's how the graph looks. Looks like that. Bless you. So now I can answer part B and C.
Sorry. Why is it less than or equal to -6 instead of just less than?
It's up to you. You can put it next to either one. It won't matter because they'll be at the same place.
But why is -6 included for this one?
Well, I didn't have to. I could have. Oh, you mean why is it? Why is it? Oh, why is it? Because it's not undefined. That's why.
Oh, but the
Where previous was undefined. That's why. Previous we were dividing by 0. We didn't want that. That's why it's okay here. Plus, originally I have a polynomial and a radical. It's okay
Okay.
because you're getting 0. It's fine. It's not a problem. So now let's find the limits. if x is going forever to the right, what's my limit? Or is there one? Infinity or does not exist. How about on the left side? If I go towards the infinity, what's it going to be? -6, correct. So we're getting a little more advanced with our use of functions here. This is what kind of makes things a little different compared to the other precalculus well, first of all, they don't do limits, but secondly, they don't manipulate functions in this manner. Pre-Fabians they kind of do. They see it more often in AP Calculus AB. But this is now an AP Calculus AB class. This is what we are like what Ms. Olson's doing. She did this in the fall. We're doing it right now. We're doing all the same stuff pretty much. Anyhow, you guys are comfortable with how I did the piecewise function? Once you have it, do the limits make sense? Yeah, and also if you just look at the function itself, if x approaches negative infinity, I know to go with this one. If x approaching positive, I know to go with this one. And 2x plus 6 is linear. That goes forever up to the right. Then I say positive infinity does not exist. Okay, that's good timing. Okay, I feel good. We got that done. I don't want to do any more notes because we got a lot more. Yeah, when we come back after the long weekend, it's back to 75-minute classes, by the way. I don't know if that's good or bad. But question on the homework you guys want to ask about? I know it's kind of long. Any questions? You guys have the answer key. We can spend about 10-ish minutes on the homework. If you have questions at all. Yes.
I think so.
Oh, for the quiz?
Yeah.
Sure. What graphic question? Okay. So for preparation for the quiz, this was some extra packets. I actually put them up today. I mean, it's still that Desmos, I mean, not Desmos, Ultimath is still fine too, but this is some extra stuff those came to office hours yesterday. I handed them out and I put on the school G. But yeah, what about 10?
The plant asymptote.
Correct.
I just like the coefficient of x on the bottom is like greater than the coefficient of x on the top, and you have to use a fraction for long division.
No. If the coefficient at the bottom is greater, it's gonna be y equals 0.
Like a negative.
Oh, sorry, the degree. Oh, don't worry about that. I'll have a fraction. Yeah, I know it's kind of crappy. I won't do that to you. That's crappy. But you have a fraction. Yes, you do. I know it's not fun. I apologize. Actually, is that even factorable? Oh yeah, because I don't know how to factor anymore. You're right. Was that right? Did I do it right? No. Hold on. There we go. Yeah, so that is factorable.
I mean, if I did it, I can do it, and then you just divide, but like, since there's less stuff in the bottom, you just do it once, right, and then ignore everything else.
Yeah. Oh, this is just an extra packet I put in school, G. Yeah. Yeah, and then you have to use long division and work it out. Yeah. But but you're fine with everything else. Okay. Okay, cool. All right.
Yeah.
Yeah, and then but you gotta use long division to get the slant asymptote. Right. I think so. I don't know. Ugh. Okay. Any questions on the homework at all?
Wait. Are there situations where only top heavy and there won't be a slant asymptote?
No, this is going to be an M behavior. There's always an M behavior asymptote. It just depends on what the degrees are. So if it's top heavy, you can have a slant asymptote, meaning the asymptote is a line that's slanted, not flat. So it's not horizontal asymptote, it's a slant out. But that's what happens when the top has a degree that's one higher than the bottom. Now, if it's two or more higher, we call that an oblique asymptote, where the asymptote could be parabolic in nature or cubic in nature, depending on what the quotient is after you do the division. I'm not doing the quiz because we haven't really practiced that enough. And I just don't want to do that to you guys. 2. Yes.
John had to do, he had to do, number 2.
Or two, where? The homework?
Number two.
Wait, oh, yes. Good question, Emma. So, yes, so factor x to the bottom. So you have 3x times x plus 2. So you could break it off like I know I'm getting lazy, my apologies. Sine 10x.
So you have an extra like review packet? Like, because he said he got it from office hours, so I was not getting office hours.
Yeah, I have some up here if you want one.
Okay.
I mean, we're gonna start the quiz very soon, but
Yeah, but I'll take.
yeah, we just want here. Yeah, thank you.
Also, across the horizontal.
Yes, and I asked her, it's right. I think all the activities we can cross, but wait, not vertically. Oh,
It just depends on like the plus or minus.
Yeah, there's 2 each. Yeah. Anyway, but Emma, do you see what happens here? So then you get 10 plus times 3 halves. So it should be 15 for that limit. Yeah. So it's got to break it up, break it apart. Correct, right. Correct. Cool. Okay. Other questions about the homework?
I never wrote it.
Nothing else? We're good?
But I put 50% left.
Do you guys want to start the quiz now? Wait a few minutes. Okay, wait a few. Okay, we'll start at 1:45. How about that? And homework's already been